Okay. Uh, if not, we are going to create two classes today, and we will uh, do something relatively new, uh, which probably you haven't done in the past, and that is we will, when it comes to dynamic allocation, we are today we will add two functions to our utils um, package to take care of dynamic allocation of memory for our member variables, and also because in both uh, milestone 3 and milestone 4, I think the most maybe challenging, I can say, or the most time consuming part is the read part. So not only we will have here for class name, which we will first create, not only we're going to have the display and then the right overloading of the insertion operator, we will also see dynamic read, uh, which means we will allow for the user to dynamically input whatever they want, and everything will be done through function in your util package. So that will give you the tool to probably, if you want, you can use these two utils functions and the concepts that we will discuss in your projects. Uh, okay, the first class we're going to create is called name. I have the template here, and I'm just going to uh, implement a dynamic member function called mValue. So this character pointer, wherever you see that we are creating these members using pointers, that's an indication that this will be a dynamic member variable, and it therefore it should be, you should consider all those rule of three and everything, and you should, this basically indicates that my class name is a class with a resource. And what is the resource? That resource will be any memory that we will later request from the operating system to be allocated to store this in value. It can be anything pointer. So int pointer, double pointer, whatever pointer. That pointer indicates that this is a class with a resource. And using the universal method of initialization, I'm just initializing this to null pointer. It's equal to say I do this null ptr, null ptr. It's the same thing. So initialize it and then come to the public, because now we have a member variable. We have to have our constructor. A constructor I'm doing here is basically one constructor that can play the role of a default constructor, and also the uh, one input argument constructor. So what I'm doing here is character constant character pointer name. So far this is the one argument constructor. Why? Because it requires you to pass a name to it, so it's not a default constructor. But if I also initialize this to null ptr, this will play the role of both. Uh, why? Because if somebody didn't send a name, this will still work, and this will basically assume that that name is nothing, is void, is null pointer, and it will still create the our class, but our class will not have a name. Uh, any question about this thing that we said? Concept? Any question about how we we put the default value and make the one argument constructor also be the default constructor? Easy, right? Okay. I'm just going to make sure in every step that we don't have any questions or anything. Okay. Now, because now this is a class with a resource, now we have to implement the rule of three, which is the copy constructor, copy assignment, and destructor. So for the copy assignment, copy constructor, I can simply say name constant name reference name n whatever, and for the operator I can say name reference operator operator and then constant name reference n. This is my copy assignment. And for the destructor, we said from now on uh, all the destructors are virtual. So we put virtual there, and we'll implement this. I'm going to have a query to get the name. So this query can simply be constant character pointer. It will return a constant character pointer. I'm calling this get name, and since it's not able to, it shouldn't be able to make any changes to member variables, I'm putting constant there. And then for the display, again, display and read are two functions that should be from now on should be virtual. Why? Can anybody explain why these should be virtual? I mean, display and read functions that we write. Why it is good or probably a must from now on for display and read functions to be virtual? Armando? Yeah, exactly. That's exactly the reason. You remember when we point to an object with its parents' names, that was when this virtuality of display and read function came handy. We couldn't see if you don't put virtual. We can only see the um, basically the parent parts of that thing, and we will not be able to see the child parts. So what I am putting here is virtual. Oh, virtual virtual std o stream reference display, and in the display again std o stream reference ostr, and it's better to initialize it to cout so that if nothing comes we know it's cout, and it is constant because again this is a display and it's not going to change anything. For the read, read part is actually virtual. Virtual std iStream reference read. So this read is absolutely essential when it comes to um, class with resources, because you definitely know that you're going to ask user to input a value, and this read becomes a dynamic read, and this becomes absolutely essential, especially here. iStream reference istr, and let's initialize that to scene. And it's not constant, obviously, because we're definitely going to read something and put it in our member variable. So we're changing our member variables. Um, and as always, operator overload for the insertion. So let's do this. It will return a OStream reference uh, operator and std OStream reference OSTR, and I'm passing constant name reference n be shown in this helper function. And here std iStream reference operator extraction std iStream reference istr and name reference, and obviously not constant because we will read things and will write them into name. Okay, this is all the things that I need for now, and now let's go ahead and implement them. Implement this one. And operator name get name and display read and insertion operator and extraction operator. Okay, very good. Now here I will need your help, and I will ask you to also comment. Uh, in the constructor, it's better to first check name and see in the name if we have a value or not, because it can be null pointer as well. So I'm just simply going to check name, and then if name, I'm going to say, okay, now I'm setting m value, and I want my a function in UT that we don't have it. First, allocate a memory. Let's call it allocate and copy name. So I'm dedicating this task to a new function that we are going to add in the util, and pass the name, and that will basically return a character pointer, and else, because there is a chance that this null pointer might come in. So if that is the case, m value equal to ut dot allocate and copy nothing, and that will make it. And we can here, as usual, add our debugging message. So if debug, we're gonna go ahead, cout, say what, created, get name, and that's it. Created this. So at this stage we created this. This is going to be the message. Now before implementing other methods, let's go and implement allocate and copy in utils. In at this stage, when we are constructing something, allocate and copy using another function is something new. Let's see how it looks like. I have some slides here. Let's see the concept first, and then we will easily implement that. Now I want to allocate and copy in a different in a function. I call a function, and in that function I want that function to allocate a memory to something, and then copy in that allocated memory and return the address of that piece of memory. So in the beginning, what I have is just an m value. Here, as in my stack memory, I only have my m value, which is this m value, created as a pointer. Because it is initialized to null pointer, it is not even pointing to anywhere. This is just a pointer created in my stack memory. Now I want this pointer be set to a state that is pointing to a piece of memory that keeps my name in it. For that, as soon as we enter this function, as soon as we call that function, now we are in the scope of that function, and this m value is no longer in the scope. It's out of scope. So this function doesn't have a clue what m value is. So this is not accessible anymore. Because of that, inside that function, I need to create another temporary character pointer, and this is how I create it. All right, fail. I don't want you to upload it, please. Okay, so we should first create a temporary pointer inside the scope of that function, because now we're calling a function. And then the next state will be, now that we created a new character pointer, we want this to point to a piece of memory, and that's why in this stage we will ask for memory allocation in that function, and that will give us a piece of memory with the size of name plus 1, because I already have name. I'm passing this name. I have the name. I'm passing the name. We know what name is, and because we know what name is, I'm already passing that. So we know we can calculate the size, and everything is clear. So we can allocate this memory in our function. The next step is copy name in this. So after allocating the memory, we will copy the name in this memory, in this piece of memory. And then when we return this temp, we basically return whatever is inside that temp, the address, basically the address, when we say it is pointing, it means it has some address value in it, right? Whenever it has some address value, it is pointing to that piece of memory. So when we are passing this, the function did everything, and then now it is returning. Basically, it is returning temp. When it is returning its value. So because of that value, my m value will also point to this place, because these are not magic, right? Now this address is copied to this address, and once it's copied, this is also pointing to that piece of memory. And when we are done with the function, that temp will automatically be destroyed in the stack memory, and what we will have is the accessible m value that is pointing to that piece of memory. Let me see, the server storage quota has been exceeded. Okay, no problem. Save a copy. Save a copy. All right. Saved. Now, got it. No problem. I don't want all to save. Okay, so are we good with this concept? Now I'm going to implement this. If there is no question, I'm going to implement this. A step-by-step, exact same thing we're going to implement here. So in utils, first let's add it to our utils.h. What is it going to return is a character pointer, right? This is the same character pointer that it returns for the m value. Allocate and copy what? Allocate and copy a constant character pointer I need here called name or whatever. And now let's create this in utils.cpp. Allocate and copy. All right. Okay, the first thing we said, as soon as we are here, there is no m value. It's out of scope. So first thing I need to create is a character pointer, something like tmp. This is that blue thing that we created in our, this blue thing we creating here. This is the temp. We're creating temp. And then after that, we said that now we want some new space, some new memory for our new temp, which is strlen. We have strlen here, strlen of name plus 1. And the next step is what? The next step is, now we should copy the name in it, and for that we can use strcopy. I am inside utils, so there's no need for ut.something something, right? Obvious. I'm using utils functions. I'm inside util, no need for them. strcopy. Now copy this name of mine inside the that thing, and return what? Return tmp. Return tmp, and we're done. See, again, one more time, we created this temp because this was out of scope in that function, allocated memory, copied our information inside that, return temp. By returning, this automatically points to that piece of, basically we are giving the address, right? we are saying, okay, now this was the address. Before I die, I'm passing you my address. Now it has the address. This now is m value is pointing to that place. And once we're done, function call is done. That temp is terminated. We're good. Now we have a piece of code that can take care of our allocation. Allocation and copy. Uh, Please be aware that we don't have memory deallocation here. We are not doing delete thingy. It's just allocating uh, and copying everything. So be aware of that. This means we are responsible for deallocating the memory for what? For m value. Every time if we think there may be already something in value, we are responsible for deallocating that memory. Okay. Uh, um, I'm not going to ask if you have any questions. Just if you have questions, just interrupt me and ask. I think we are done now with this one. Name we did, the constructor we did. Now for the copy constructor. For the copy constructor, I can simply say I want everything be done with the operator assignment. I can simply say this, and and ask my copy assignment to do things. And because I want to see this, I'm putting another debug message here. I want to see this in action, so I'm putting create what? Create creating a new object, uh, and a new name, a new name, and uh, copying copying what? Copying something here. Uh, Copying now n dot m value, copying m dot m value to it. That's it. This message will show me whenever copying is taking place, and it will be easy to check if this worked. Now, after that, now copy assignment. For the copy assignment, the most important thing, the most important part that we should consider, apart from the fact that we want to prevent copying something in itself, which we check by doing this. We don't want this to be equal to the address of n. So if these things are not equal, then what should I do here first? Please, somebody. What is the first thing now I should write here? I'm going to ask, just select random user, Sebastian. It selected you. Sebastian, what is the first line I should write here? Okay, so here we are writing a copy assignment. It happens when in the main you want to say a is equal to b, right? This is when this copy assignment will be called. For that, because the left side, because this a might already have some value in its m value, and we said that allocate and copy is not deallocating memory, the first thing we should do here is to deallocate it, and we say delete m value first. Get rid of m value of the left hand side of my copy assignment because it might have some value in it. And then simply say m value, then use that ut's allocation and copy thingy. Allocation and copy function, and do what? Do copy m value in that. That will be the copy assignment. If and then if this is true, and we need to return this, right? We need to return this, and we are done with the copy assignment. And here it is simply delete m value, right? Simply delete m value. And what else? In the get name, we can simply return m value, right? And in the display, we are going to return um, return, and we say return. Here we can say return return ostr m value, right? M value, because we want to show the m value. And for the read, okay, now for the read, remember now why do we use read? We use this read to basically to show a prompt to the user and ask the user to input its data. So first we can basically in the read, let's show that prompt, stdc out, enter a name, and then after they enter the name, now we want to read that name, and put this in the m value. But this m value might already have something in it, so we are just deleting m value, delete m value to make sure it's empty, and then m value is equal to what? Can I use that allocate and copy function of mine that I just wrote? Let's ask somebody again. Can I just use that allocate and copy function of mine I had? Tran, your name came up. Can we? We can reuse, but there is another problem. I don't have a name. If you look at this allocate and copy, in allocate and copy, I'm sending a name or a value to be copied, but here I don't even have that value. I have to first obtain that value. I have to get that value from the user. So this is just here. You mean which line? Line 50? Exactly. That's what we're going to do. But we're going to again write another function to so that we can reuse that, put in our utils package so that we can reuse that. And I'm calling that dynamic read, and I'm sending this istr to this dynamic read. Then it will just return the istr, right? It just returns istr, and we are going to write this dynamically read function now in our utils. In our utils, I'm going to add this. And what will this return? Again, it will return a character pointer, and we said it is dynamic read, right? It is dynamic read, and this is going to get std istream reference isr. Okay, now let's create this in the isr, and then I'm putting here, and come here, find dynamic read. Okay, in my dynamic read, the only difference is that I don't have a value to copy. Everything else is exactly like allocate and copy. The only thing I don't have is the fact that I need to ask my user to input a data. So let's create that character pointer, tmp first, and then after that it looks like this. When in operator equal, when we want to it's this one, dynamically read. When we come here, we want to read something dynamically. First we are in this stage, we deallocate it. Now we are in this stage, create this temporary variable, and we need now a temporary storage which we can use a string header file, a temporary storage and getLine function to fill in that everything. Now this solves my problem, and once I read dynamically with getLine and store everything here, we can then say, okay, now now I want a new memory allocated to this, and then copy the data here, and after copying, return this, and by returning this we end up pointing to a new dynamic memory which was also dynamically read and filled in, right? This is the difference. So here after this, so I think I have a string header file over there. I'm good with that. Here I want to create a string so that I can keep my stuff in that. And after creating that string, I'm gonna get line, and in this get line, say isr and sts and a delimiter like a new line. So this creates that temporary part for me, that temporary storage for me, an object, a string object, and then get line, I'm getting everything in it dynamically. I'm reading a line from the console, I'm putting in sts, and if that read, we can check if that read was successful, it didn't fail. How it fails? For example, you're looking for you're looking for a string, but nothing is, and just for instance, a tab is inputted. So these are the times when you are expecting something, some type, but user input something else. That's when the cin object or any input object can fail. If this didn't fail, so I'm allocating, well, we can now use this allocate and copy, because the rest is just similar to this. And now I have my input in the basically in this object, where in C string part of this object now has my has the inputted string, and I simply return tmp again. Simply return tmp. This is exactly doing this, deallocating the memory. Uh, we did deallocate the memory. Deallocate the memory first, and then a temporary pointer, uh, temporary part to store the user input. This is that C string part of this object. So in that object, then copy that, allocate a new memory, copy that. This together, two steps together, is done by allocate and copy, then return, and then we're good with this function. This one also implemented. Okay. Any questions? Any questions? The question is, any questions? Okay. Now coming back to our name.cpp. In our name.cpp, now what I have is we also implemented this read, and then here for the operator we can simply return n dot display ostr, right? And for this one I can simply return n dot read istr. We are done. Let me build this, see if there was a mistake or not. Okay, build successful. Now I already have my main here. In our main, we want to test now if it worked or not. First of all, I'm turning debug on, then uh, Eric Moore in the name n1. So this will basically test the constructor, and this will test the insertion operator overload. We are creating another name object. Here we will test the copy assignment, and in this one we are basically showing n3. And to test copy, how do we test copy constructor? I had to basically write another helper function to with passing a value, not the reference or pointer, but passing the value, so that this this n1 of mine that I'm sending to this gets copied to n, so that we can test that copy. And here we try to read something from the input, and that something is whatever we input gets stored in m value, and then it shows that this is stored successfully. Let's see this in action. Okay, what is the error? Class main line 24. Okay, got it. And run this. Once we run, we see now we have created Eric Moore. Then it is showing Eric Moore, and it is creating John Doe. It is showing John Doe. Creating a new name. This is the copy assignment we implemented with this message. Now it is creating a new name and copying John Doe to it. It's showing John Doe. It is creating a new name and copying Eric Moore to it. Now, because of this copy assignment we have here, it is copying that and showing Eric Moore, and now it wants me to input another name, which is Peter Parker. Peter Parker got copied in N1, and it is shown, and the program got out successfully. So this was basically, so far it was related to the things that we knew from the past. Just reviewed a little bit, made things more modular by adding those two functions to our util functions, and now we have them. Is this okay? If there is any question about this name module, let's discuss. Any question? Okay. If no question, uh, I'm gonna open another project. Now, we might want to actually implement here. Implement another class that is derived from this class, and uh, it has the same name module in it. Now we are deriving another class called full name from that, and we want to see how we should handle some stuff. Me also here, this one, also open this code. Open in my notepad. Okay. For the for the uh, for the full name, now we are going to say our full name is going to inherit from class name, and we're going to add another member variable that has a resource in it. Character pointer m last name, and initialize it to null pointer. So now I have this uh, character pointer and last name. In the public part, I'm going to have the rule of three again. So say this is full name, constant character pointer. Now, because it is inheriting, now I should have name, both name, null PDR, and the last name, and the constant character pointer, uh, last name, again, null PTR. Okay, and uh, instead of two queries, let's write only one query to get the uh, and by the way, this is, let me put it here, and rule of three. Now copy constructor, full name, my full name is constant full name reference f, right, and then full name reference operator equal constant, again, this thing here, and destructor, virtual destructor, full name, again, virtual destructor full name, and in the queries, constant character pointer, get last get get last name, constant, and read and display. Again, it should have its read and display thingy, exactly same as what we had for the name. So I'm just copying from there, copying here, right? It's just the display we have here, or we can even don't implement this because it will have it by default. So this is kind of redundancy, but I'm still pasting here, constant, and now that we have these, overloads are also the same. Overloads, now we have these overloads here with instead of name reference, we just have full name reference, and here instead of this one is again the same thing, we have full name, and here it is full name reference f and if. uh, okay, so the new parts here actually are implementing the copy constructor, the new parts. The rest we already know, but these are new parts. For the copy constructor, for the and then for the copy assignment, and virtual. These are the things we discussed in our PowerPoint last on Tuesday, and we can still refer to those. Let's play Oh, by the way, this read and display are not completely redundant, because now we have the new member function in the child, which is m last name. So we will implement these two. Okay. When it comes to the the constructor, I can, just like what we did in the past, I can simply say, now I'm using the name part to initialize my name, and here what I need to do is just again check, because name will be checked by the constructor of the name. So here we did that, and here I'm just checking if last name exists or is not null pointer. I'm just gonna go ahead and say m last name is equal to what? Ut dot allocate and copy last name. Why? Because this class also has resource. This m last name is also dynamic, so I need some dynamic memory allocation and copy together merged in the thing and done for the m last name, right? Else, if last name was not a valid thing, or was just a uh, null pointer, what I can do is m last name is SUT nothing, but this time put nothing in there. This will take care of our construction. And if debug, again let's write a message, if debug cout creating get name. I have get name, creating get name, space, and get last name. Get last name and done. Now, what can I do for the copy constructor? Now, what is the problem? First, we discussed last week, we said that for the copy constructor, child class destructor, copy assignment, copy constructor. For copy constructor, we said that the problem was we have now two things that have their resources. One of them is the parent part, the other one is the child part. And in this example, name has its value, dynamically allocated value, and also last name comes in play in the full name. So we have to, in the copy constructor, we should be able to deallocate the parent part and allocate some new memory and put the new name in it, and deallocate the child part, allocate a new memory and put something in that. We said that there were two options, option 1 and option 2. Option 2 was the easy option, as similar to what we did for name. We can simply say, okay, forget about this copy assignment and let copy assignment take care of this. So I just want to simply write operator equal, pass the object, and done. So the only in this scenario, the only thing that you should worry about is your copy assignment. But sometimes using this is not possible. We will see when it is not possible in a minute. Option one was to now if I want to use this, let's use just like what we did in the constructor, in the default constructor, uh, or the one argument constructor. Now let's use the constructor of the name, it's the copy constructor of the name, to take care of the name part, and then we just worry about our own part. This was the option one. So now let's do it with option one first. So if this is the case with option one, this is the new thing that we see for the first time probably. That here, just like uh, the the default constructor or the one argument constructor, you can also come here and say, okay, go ahead. By the way, don't forget this is like this, right? This doesn't matter. It can be braces or curly braces or braces. Uh, so this is a copy constructor, right? So this is the same thing. I'm using the copy constructor of the name and letting this take care of the parent part, and uh, because over there I have everything set, I won't worry about memory leak or anything like that because name is written very precisely. And here what I will do is just say, okay, now I want to allocate something to my last name. Allocate and copy f dot last name, right? F dot last name. Sorry, f dot m last name, right? Why is it giving me error? Okay, no. M f dot m last name. Oh, spelling error. Is this part okay? Does it look strange? If you say yes, you have to ask a question. Three people have not answered yet. Does this mean they're thinking? Is this strange that we are doing the same thing? We are using the same part of name that we learned in the constructor part now in the copy constructor. This is a constructor, right? So we're doing the same thing. And this with this one, option one, you can always do that with no restriction. When it comes to, and consider here in name, by doing this in name, uh, I don't have the default constructor. This is not default constructor. That header. This is not the default constructor, right? Because I don't have I don't have the default value for this. So it's one argument constructor. Now let's go see what happens if I do this. Uh, let's comment it and do this. Now, similar to the past, I want to say what operator equal, uh, just like we did operator equal, and then pass if. This should also be fine. Why am I getting an error here? This won't allow me to do things. Uh, in the second version of the copy, uh, we are just like before. We're saying, okay, I'm not gonna implement anything here. I'm just gonna say operate this assignment operator overload will take care of everything, but it's not allowing me to do that. And if I run this, I will face an error, hopefully. Uh, and that error reads, no default constructor exists for class name. And we know there's no default constructor. In fact, that's what we know. I don't have a default constructor here. And I'm getting this error. But why is it giving me this error here? What do you think? Think about it for 30 seconds, and I'm going to select somebody, or if we don't have any volunteer, I'm going to select somebody. So let's select someone. Alfred, it selected you. Are you there? He's probably not. Uh, it's selected Yi. Yi Liu. Are you there, Yi? Why do you think we are now getting an error of this type when we are trying the second option? I'm not going to implement my copy constructor here, and instead I'm going to let everything be done by the copy assignment. But I'm receiving an error here saying no default constructor exists for class that we know, but how does it relate to that? It's totally okay if you don't have any idea about it. We're just discussing. Okay. So, thank you. The answer is, isn't it? What is it? This is A equal B, right? This is, or sorry, this is when we are copying things, right? When we want to copy stuff. For instance, we are passing this f to a function, and that requires copying. When copying, there should first be something, some object created. And then after creating that, we put the uh, the second part, that the right hand side, we put that right hand side in that created thing. Here, when it comes to this copy thing, first, that full name object must be created. But we are not doing this. We are not sending any information to the constructor of the base class. So when it comes to construct that object, it comes down here and it sees there's no default construction, and without a name being passed to that, name cannot be created. When name cannot be created as the first floor, as the base floor, its child, which is full name, cannot be created either. So that becomes an issue. So remember, this is basically a new thing. We didn't have this problem when we had only one class with resource, no inheritance, no derived classes. But here, if you want to use your copy assignment uh, and don't implement this copy constructor and instead use this copy assignment, your base class should either have a default constructor like this, name just the default constructor, or use your uh, use your uh, use your one argument constructor by giving a default value. I'm giving null pointer here, null pointer, and change that to a default constructor, like it plays two roles. Now here, when this object is going to be created, even though we are not passing any information to the constructor, but it's still, because it has a default value and it looks like a default constructor, if we don't pass anything, this will work. Now by adding this error went away, and I guess we will be able to compile this. What is this error? Full name must return a value. Yes, you're right. So we're going to return this. Return this. And then let me build it. What? Uh, no, what was that? No, what am I doing? Turn this. So what was this error? Creating this. Here, can I build it? Build. Full name, line 32. Ah, it's, yeah, okay, of course. So let's go ahead and implement other parts as well, and then we will see how it works. Or I can maybe say return. This is return. Return this. How about this one? Okay, so now let's go ahead and implement these. So this is the take-home message. I want you to know, in your milestone 3 or 4, I think, it asks you to implement a default constructor. If you have a default constructor in the base class, there is no limitation for this, and you can use copy assignment in the copy constructor part, and don't implement that. Basically skip that part. But if not, if you don't have a default constructor, this is the way you should implement this. Use the copy constructor of f, pass the information in the initialization area, and then allocate memory and copy things to the member variable of the child class. And let's complete the other parts as well. Now for this copy assignment. Now again, in the copy assignment, I have two parts that I should consider. One of them is the name. I can use the for copy assignment. We can use the copy assignment of the parent first and send simply f. Why can I send f while name operator accepts name reference? Is it okay if, see now, if you look at this, this operator accepts name reference. So how come I can just send f here? So, does somebody want to answer? So the answer is easy, because we said that whenever we are referring to a child with its parent reference or pointer, the child forgets that it's a child. It acts like a parent. So here, f suddenly becomes a name, not a full name anymore. And once things are taken care of here, what we do is we delete. Now we are good with the name part of this. For the last name, because it's operator assignment operator, there may be something in the last name. Delete m last name. That's why we should delete it first. There may be something in it. We deallocate that memory, and then we say m last name simply is equal to ut dot allocate and copy what f dot m last name, and this will take care of everything. For the deallocation was another important part. So we said this, we coded this as well here. So what I showed you was this copy assignment. Use base class copy assignment, deallocate, and then allocate. For the destructor, we said that. Now let me see. Do I need to say delete? If I just write delete m value, will this be okay or not? Am I missing by writing this only? I don't care about deallocating my base part. I just care about deallocating my child part. Am I doing a correct thing or no? Am I missing anything? Let's put a poll. Is something missing here? Please say yes or no. Is something missing in the destructor of full name or no? Okay, two people said yes, one person said no, two people have no idea apparently. Okay, now we have three people said yes and three people said no, one person said, two people said yes. Tran and Liu, you said yes. Why do you think we are missing something, and what is that we are missing? Yeah, go ahead, please. Okay. Well, this is it. You mean after this, say M last name, uh, yeah, null p. Well, this doesn't make any change. Why? Because this is the destruction level. So after this stage, imagine this program is going to end, and when it ends, there is no M last name or anything like that. If I put it here, it is fine, but this would be redundant. Even if I didn't put it here, this would work fine with no memory leak, no anything. Obviously we don't have memory leak because of this, because we have deallocated the memory, and obviously we will not have any problem with M last name pointing to something, some stupid area in the memory, because this is the destruction level, so it is going to distinct, and this will no more exist. I'm not going to use this anymore. That's why this wouldn't be a problem. uh, Then your answer is no. Okay. Uh, how about Tran? You also said yes. What do you think we are missing here? Let me take this out. Good, good, very good point. Actually, this is what we wanted to discuss. Excellent point. So, Tran thinks still uh, we have the name part. We have this name here. Uh, that requires deleting. Where is it? Requires deleting. It is true, and it is actually already taken care of. Why? Tran is completely correct. When we have allocated two parts in the memory, one of them was for the name, the other one was for the last name, and we are deleting the last name. We are deallocating the last name. So how about the memory allocated for the first name? The answer is, remember, every time a destructor was destroying the first level, it was also destroying the base level. We said that when, just similar to construction, when a child class was being constructed, first we had the base floor was constructed, that the base basically the parent object was created, and on top of that floor we created the child class. And automatically, for the destruction, when the compiler is destroying a child class, it first destroys the child, it first calls the destructor of the child class, which in this case is full name, and then definitely it never forgets to also call the destructor of the uh, base floor, the base object, the parent object. As a result, when we are, even though we know that there is another resource for my parent, but I don't need to worry about that, because I know that whenever a child's destructor will be called, immediately after that, the destructor of the base class will be called. And in the base class, we have already implemented this deallocation of the M value. So there will be no problem. Actually, this is complete. So that's why in the slides also we said, for the destructor, don't worry about the resource that was allocated for the base class. Just worry about what you currently have in the child class and get rid of that, because that base part will automatically be taken care of by the compiler. Does this make sense? If not, you can ask your question. Okay, apparently yes. And then for the now, what else we have? We have get last name, so we simply return last name. Easy. Now for the read, and by the way, I remembered something now. For the destructor, since destructor of the name is virtual, if somebody comes from the talks about the exact opposite scenario. Now imagine, where is name? Name destructor here is virtual. If somebody says, okay, now what if I am storing a full name in a name pointer? What if then? That's easy. That's what we know from the past. In that case, because the name is virtual, this will go and destroy the last name first, and then because automatically compiler knows that it should also destroy the base floor, that will also be destroyed. So still in both cases, either you're directly want to destroy the child, you're fine because base will automatically be called. And if you're calling from the base side, because of the virtuality, will pass. The destructor of the child will be called, and after that, automatically again the compiler will go back and destroy the base. So either way, we are immune and safe and no problem. For the display, now we have two parts that we want to display. The first part, why not use the display of the name, OSTR, display this name, and then with some, maybe because we know it's name and last name, we just put in a space there and say last name, last name, and then return OSTR. This can simply be our display. And let me check, we are still recording, yes. And for the read, again, same concept. For the read, we actually implement this, if we want, implement this with, I don't know, just read the name and full name all together. It might be challenging. So because there's already space between name and last name, so let's just say prompt the first name, first name, prompt the first name, and then once prompt, then we use the read from the name part. We read and send ISTR. Then we send another prompt, enter last name, enter the last name, and after this prompt, enter last name. Now this is because the read part automatically took care of deleting things, everything here, it took care of that. But here for the last name, we are going to implement this manually again. First, delete the whatever that we had in last name, deallocate this, and then say m last name ut dot dynamically read and send istr, right? And then say return istr, return istr. Uh, is this okay? Is this um, read that I implemented for full name okay? Or you think something is missing? Is it okay? Okay, apparently yes. Apparently yes. And then coming to the now the only remaining parts are now here just return f dot display, f dot display, and here return f dot read, return f dot read istr. Okay, let me build this first. Okay, build successful. And in the main, uh, I am implementing an I'm initializing a full name object. I'm instantiating a full name object, then asking for the name. Now here I'm checking if my read works. We should be able to read last name in it, name and last name and everything in it. What's your name? So name and last name. And then we are checking the insertion overload, and here we are checking the constructor. Here we are checking again, showing that this other has been created, checking our copy assignment, and if we see that this other became name, then copy assignment worked. And here we are checking copy constructor by again another helper function that we have here. Now let's see this in action. Let's run it. Now it says, what is your name? Enter the first name, enter. Okay, it got it inside name. It read it inside name actually, name and last name, full name. It shows welcome. It shows welcome, last name, first name and last name, and then it tests the insertion overload. It shows John Doe, and then after it shows John Doe, it shows that now this name was Hamed Tabrizi, and this other was John Doe, right? So we copied that. Now it shows Hamed Tabrizi, assignment operator checked, and Hamed Tabrizi copy constructor checked, because we are showing this message here. This is also checked, and we are good. So in summary, when you are implement, you will see this in a milestone 3, milestone 4, and probably in the final exam, in everywhere. When you are implementing copy assignment, copy constructor, and the destructor for a class that is derived from a class that has a resource. For the destructor, it's easy. Forget about the base part. For the copy, copy assignment, use the copy assignment of the parent and then delete the resource for this one and take care of the basically the child part. For the copy constructor, you have two options. Either ask your copy assignment to do the task, and in that case, you should have a default constructor in your base class, or implement it like this that we implemented. Use the copy constructor of the base class and then take care of the child part of it. That's all for today. Is there any question? Okay, if not, we'll see you on Tuesday. We will probably talk about IO refinement, and then if we have time, we will move to templates. Uh, if no question, I'm going to call it a day. In public chat, do we have something? Thank you, Yilu. Thank you guys for listening. And we'll see you on Tuesday. Have a great weekend. Thank you. You too.